Hello everyone. In this video we're going to be taking on a magnificent piece which was made by the Crocker-Wheeler company. And this company actually started out as Curtis and Crocker and then became Crocker and Wheeler. They were originally based in New York and then they moved to New Jersey in about May of 1893, and this piece has the New Jersey tag on it, so it postdates that 1893 move. Anyways, Mr. Wheeler is an important figure in the history of electric motors and electric fans. Some folks credit him as being the original inventor of the electric fan, although that's open for some debate. There were some other early gentlemen like Johnson and Bergman who also had early fans going at about the same time. So that's not written in stone, but he does widely get credit as being the inventor of the fan. Anyways, this company was a prolific producer of motors, dynamos, fans, and there are some of them out there today. You know, I wouldn't say that they're extremely rare by any means, but they are extremely sought after, and the demand for their motors and fans far exceeds the supply. Consequently, they're still pretty expensive when you go to buy them. Anyways, I'll bring the camera in and we'll take a look at this piece. So looking here at our tag, we can see the patent dates of 1891. This motor is a 1/6 horsepower, which is very substantial for a fan. And you might be able to read there, it's a type TM. And the TM motors were 2-speed motors. I'll move the camera around. Let's take a look at the switch on the side, and you'll get an idea how this thing functions. So if you look at that switch on the side, you'll see that there's 4 contacts on there. And you'll see that that little knob has 2 contacts. So the way that it works is that small contact on the knob, this one here, when it's on slow speed, just that contact is shorting out connections 2 and 3. And what that does is that places the windings in series. And when they're in series, it runs slow. When the knob is rotated completely around, then the small contact here is shorting out these 2, and this one is shorting out these 2, and then the windings are in parallel, and then it's running at the fast speed. I do have a little diagram I found online. I'll show that to you real quick. I actually attempted to draw a diagram, but that was a failure. So we're going to go with this one that I found online. I don't know who drew this, but thank you. Anyways, you can see here, reiterates what I told you before. When the motor is in slow speed, contacts 2 and 3 are connected together, and that places the field windings in series. When it's on fast speed, contacts 1 and 2 are connected together, and contacts 3 and 4 are connected together, and that places the windings in parallel. Prior to turning on the camera, I did clean this up a little bit and brushed off some of the dirt and gunk that was on there. And I also added oil in these oil wells. This thing was stiffer than I thought it should be, and I just wanted to see if it would free up by adding some oil in there. So that oil that you see on there is from me. I didn't do any work as far as taking it apart or anything like that is concerned. Just a little cleaning and put a little oil in there. So anyways, as with any project, I've already taken some pictures of this thing before we start taking it apart. We're going to take our time on it. My intention is to leave this as a utility motor. Somebody else was using it for that function. That's why it has this pulley on there. I didn't put that on there. I'm not going to turn it into a fan, although that's probably what most people who got this thing would do with it. We'll just leave it as a utility motor. Anyway, let's get started. I turned off the camera. Getting those screws out of that tag ended up being a little bit of a project in itself. Hopefully the rest of the project is going to go easier than that did. I don't want to show 10 minutes of getting the tag off. Beautiful, solid brass tag. Now we'll try to get this pulley off of here. Just held in place with a flat head set screw. Okay, that's on there. Probably gonna have to get the puller out. Let me do that real quick. Alright, I'm able to get some movement out of this pulley using the brass hammer, so we'll just carefully tap it off of there. This is just a pot metal pulley, so this is obviously much later than the motor itself. Let's go. There it is. Okay, beautiful. Okay, let's take these plugs out for the oil wells. If any oil comes out of there, remember that's what I squirted in there. Yeah, it's coming out a little bit. Looks like there's a little washer there. The other one, there's a little oil reservoir cover here we're going to take off. It's missing on the other side, so we'll probably have to fabricate another one. Now let's pull these brushes out of here. These just unscrew. Take that off right away. Let's do the other side. One brush is chewed up, one brush is intact. Don't know what happened there. We can take this off right away. Okay, we'll start taking these brush holder assemblies apart. Take a look at what I need to do here. Screw holds the terminal in there. Screws holding the spring in place. Okay, now let's take this off here. Alright, the bolts that secure these housings in there to remove the rotor are really tight, so I'm going to continue with the easy stuff first, and then we'll work our way around to the more difficult pieces. A lot of these screws have been really hard to get out of there. I could tell that this thing hasn't been taken apart before, so everything is in there real tight. I mean, it appears that I'm the first one to take this thing apart. So let's start with the easy stuff first, and we can work our way around. This nut appears to have a bad thread on it. I have to tap that.
Snip these wires. Switch. We'll take that apart further, obviously, but for right now, just leave it there. Get this bracket off of here. Front brackets. These we probably won't put back on there. They're not really hurting anything, but we'll see. Getting these bolts out took a little. I soaked them all in a little. So, let's try to remove this housing. Now this does have ring oilers, which speaks to the high quality construction of these things. Let's see, we should be able to pull the rotor out here, hopefully. Hopefully. If I'm blocking the camera, I apologize. Okay, we got our rotor out. And the rotor is covered with this like vulcanized cloth. Of course, that's completely dry rotted. We'll have to replace that with something else. It's a pretty heavy rotor, really, for the size. Set that there. There's a spacer washer here, which we'll make note of. There it is, most of the way broken down. I haven't pressed out the bearings. They seem to be in pretty good condition. If I need to change them, I will. They're still in the housing. And these insulating washers right there were really stuck on there, so I just left them on there. I mean, if I took them off there, it'd probably break them, and there's really no benefit to doing that, so we'll just leave those in place. Start getting things cleaned up. I asked around to a couple people because I was not sure whether or not this coil could be removed from the shaft without damaging it. You know, it occurred to me that perhaps the coil was just wrapped directly around the shaft, which would prohibit its removal. So what I found was on the Crocker-Wheeler branded motors, the coil can be pressed off, but on the older Crocker-Curtis models, it cannot be pressed off. So I'd like to thank Alan and Dan and Chad and some of the guys who I reached, Paul, some of the guys who I reached out to in reference to that. So now with that knowledge, we're going to go ahead and we're going to take this off of here. All right, we've got our coil set up on the workbench. First thing that we're going to do is I'm just going to clean this area here with a little WD-40, nothing major. And I'm going to use a nylon brush and just clean up any corrosion that's around there, at least a little bit, so that when we go to press it off, that corrosion is not working against us. Pretty good there.
If you look right there, you could see there's like a little tab that was chiseled into the shaft when they manufactured this. And you need to make sure that those tabs are not impeding the movement of the coil from sliding off. So I ground those down a little bit and they're clear. So now we're going to take this whole assembly over to the arbor press and we're going to carefully press it off.
The other thing I did was I put a little witness mark on the shaft so that when I put this thing back together, I could put them back together in the same orientation that I took them apart. This is the setup we're going to use for pressing out the shaft from the coil. I got that as far back as it'll go without damaging that wire. Should be good enough for what we're trying to do. Now we are carefully going to press this out, and I do mean carefully. Go. Just pressing on it lightly. There it goes. Got my hand on the bottom here. Now it's not all the way out. Got the socket here to push it out the rest of the way. Hopefully. There it goes. Okay, perfect. Here they are, completely removed. If you look there, that's that tab I was talking about on the shafts. So we've gotten this thing broken down as far as it's going to go. I went ahead and degreased the base. And the paint on this is not bad. I think it's salvageable. What I'm doing now is I'm trying to clean up the machined surfaces on here, particularly inside these bores where there was some corrosion. So a perfect tool for that is this flat disc and the Dremel. Running it in there, polishing everything out. On this base here, I'm using my precision ground flat stones. I'm just knocking the burrs off those machined surfaces. This is really overkill for this, to be honest with you. It doesn't need to be that precise, but since I have the tools, might as well use them. You could actually hear it picking up those burrs in there. Unlike the base, these posts have lost a lot of paint. You can see there, the other one is just as bad. I think I'm going to go ahead and just refinish the posts themselves, and then we'll kind of blend it into the base, and we'll leave the base with its original paint. Of course, we want to try to keep things as original as possible. These bearing housing assemblies are beautifully cast out of solid brass. What I did was this one on the left here, I aged it a little bit just to darken it up, have a nice authentic appearance. I think when I put it back together, I'm going to leave that like that as opposed to painting it black. It was painted black here, and then the brass parts were sticking out on the ends, but I think I'll leave the whole thing antique brass like that, and we'll see how it looks. If I don't like it, I could always paint it later. I'll go ahead and age this other one up here. Alright, I'm happy with the way that these bearing housings look. We're just going to apply a little bit of high quality wax to them, buff them out a little bit. We'll set those on the side until we need them. If you watch my videos, you know I like to use this carding wheel to clean up my brass. It's a soft bristle brush. It does a nice job of leaving a low luster on there. It cleans but does not polish, and it's perfect when you're trying to preserve these antique pieces. See how beautiful that is? Low luster, clean, but not too shiny. I'm going to go ahead and clean up every single brass piece in the same fashion. One of the nice parts of having things that were made by hand is you see little imperfections like that. This nut must have been machined on a Monday. That hole's pretty off center, but you know what? It's been working for 130 years. I'm gonna put it right back on there. I'm working on cleaning up the nameplate. It has a pretty substantial bend in there. Let's see if I can just put it in the vise here. Straighten that out. I do have a sheet metal hammer if necessary. Pretty good right there. I'm going to fine tune it with the sheet metal hammer. Call that good. I think that looks perfect right there. I removed some but not all of the imperfections. It looks clean but it looks old. I'm going to put a coat of the Renaissance wax on there. I'm going to call that good. This washer right here has a pretty bad split in it. I'm going to go ahead and I'm going to try to repair it with some JB weld and then try to make the repair invisible. It's the lesser of two evils. To me, it's better to have a repaired piece that's still original than to machine a new washer. So we'll try it out and see how it comes out in the end. Alright, we're going to clean up our JB weld. One nice thing about having a variable speed AC motor, you just dial that down a little bit. That'll do it right there. That looks perfect right there.
you may recall that when we removed these pillars, I had to use the arbor press in order to press off these coils. When I put this thing back together, I don't want to have to use the arbor press to put this back on there. So I'm going to set this up into 4-jaw chuck, indicate it, and I'm going to take just a light skim cut off of here, the lightest cut possible, just so that this will be a tight slip fit on there. It has to be tight enough that the magnetic action, happens, but I don't want it to be that tight. This winding is 130 years old. It seems to be in pretty good condition, and we want to be real careful not to damage it. So I'd rather be able to put this in snugly, but put it in by hand. So we're going to set that up in the lathe right now. I got it dialed in, taking off 20 thou right now. It's not even cleaning it up. So I'll probably just take off maybe another 10 or so, and then I'm going to try it and see how it fits in there. Alright, if you look at the one I turned down, all I really did, I took a total of 30 thousandths off of there, and all I really did was just take off that heavy casting line right there, and just that is enough for this to be able to press in by hand. I just tried it, so we're going to leave it just like that. It fits in there nice, but I won't have to use the arbor press. I'm going to go ahead and do the other one exactly the same way. Here's the second one. We just took off that heavy casting ridge right there. Now they fit in real nice. The next part of the project is going to be working on these coils, and they're going to have to be rewired here where this is all dry rotted, and that's going to be a more difficult project than it would appear on the surface. Splicing a new wire on here is not the difficult part. The tricky part is to make it look neat when you're finished. Ideally, what we would want to do is remove this ring and then make the splice underneath the ring, put the ring back on. But in order to remove this ring, you're going to have to bend this flange here or grind it off, and it would be a big project, and the risk of damage and the risk of a poor looking job when you're finished far outweighs any benefit of doing that. So the splice is going to have to be made here on top where it's visible, and then after we make that splice, we're going to have to try to conceal the area where we soldered the new leads on, and that's going to require a little bit of artistic interpretation, if you will. Over here I have some pieces of my cloth covered wire collection. I'm just taking a look. This is the original right here. Just taking a look and seeing what I got. This motor only draws a couple amps, so any of these wires will be fine for that. I think in this instance, I think I'm going to use the black one here, and we're going to get this set up, and we're going to start getting these leads cut and cleaned, and we'll start soldering them on there, and then we'll figure out a way to conceal the area where we spliced it together. So let's get started. It may seem counterintuitive, but these tub of towels are absolutely perfect for cleaning off old grime, old cigarette smoke, things like that. And that's exactly what we're trying to accomplish by cleaning up these coils. The tub of towels does a good job cleaning, and it's very gentle at the same time, which is exactly what we're looking for. So we're just going to clean up these field coils using the tub of towels. And we'll just keep changing out the towels until they wipe clean. Picking up a lot of dirt, working like a charm. So I'll go ahead and give this thing a thorough clean, and I'll bring you guys back. I think what I'm going to do is I'm going to put a coat of Japanning in these pillars be very durable. If it's a little shiny when we're finished, I'll just tone it down with the steel wool to blend it into the existing finish on the base. Anyways, the issue that I have here is my little toaster oven that I use for the Japanning. These pillars are a little bit too tall to fit in the oven vertically, so consequently I'm going to have to make a little fixture where I can bake these in a horizontal position. I'd like to do them both at the same time if possible. That'll save me several hours of baking. So I'm going to go ahead and whip up a little fixture, and then we'll get some Japanning going on these. I took my Dremel tool and I cleaned up these pieces just a little bit. I didn't change them too much. I just refined them more or less. We got our simple fixtures made, one to hold the Mickey Mouse nuts and the other one to hold the two pillars. I got a little batch of Japanning mixed up. Some of my other videos I showed this using the liquid asphaltum and the boiled linseed oil. It's got to bake at a couple hours at 200 degrees, then a couple more hours at 385. So I'm going to go ahead and get these pieces cleaned up with some acetone, and then we'll get them coated up and we'll get them put into the oven. We got our pieces coated up with the Japanning. Now the Japanning is self-leveling, so I'll let those pieces sit for about a half an hour, and then if I need to go back and brush out any drips or anything like that, that'll be the time to do it before we put it in the oven. All right, we got our pieces in the oven. This will be the first of 3 coats that these pieces will receive. This is a very time-consuming process. Obviously, it would be much easier just to paint these and to clear coat them like most people would do. When you get involved with Japanning, you know, it takes a lot of time to do it, but it really looks beautiful when it's done. So that first coat that we put on there, it looks a little bit translucent when you put it on there, but as you put the other coats on there, then it will be opaque. That's the final coat of Japanning. Just going to run it through the baking cycles. I tell you, I really love how that Japanning looks, and I also like the durability of it. I took the freshly japanned pillars and I beat them up a little bit, so to speak, using some steel wool on them to knock off the high sheen. And then I hit them with a coat of wax and they blend in real nice with the pre-existing finish on the base. I'm going to start cleaning up this armature. This armature is wrapped with like a vulcanized fabric, and just from touching this, it's already falling apart. So we are going to have to put something on there to protect that. There's no salvage in that stuff. It's completely dry rotted. It's just falling apart here. I'm going to start off with just a soft bristle brush. Give this a light cleaning. This armature looks to be in pretty good condition overall, to be honest with you. Nothing major here other than the wrapping. That's to be expected for 130 years old. Oh, let me grab another can of contact cleaner, and I'll get this armature all cleaned up, and we'll bring you guys back. I'm going to go ahead and take a cleanup cut on this commutator, which, to be honest with you, I'd prefer not to do on such an old armature because you always have a risk that these laminations could pop off of here. But what happened was, you see these striations in the commutator. Somebody allowed one of the carbon brushes to run completely down, and the brush holder ran into the commutator, and there's some striations in there. So in order for this thing to run without sparking, I'm just going to take just a light cleanup cut on it and get rid of those striations on there. All right, I've already touched off on here. I'm using a CCGT insert, which is made for aluminum. Does a good job on copper and other soft materials. I'm using a little WD-40 as lubricant. We're set up for a 10,000ths cut. I got a indicator set as a stop. And Let's try it, see what happens. We might not even be cleaning that up all the way. We'll have to take another pass. That rumbling you hear is the mica sections. Okay, it's not quite, well, let's see. One more pass. Okay, this is our second pass, 10 thousandths. Should clean it up this time, hopefully. Perfect. This glue remains flexible when it dries. It's also acid free, so it's perfect for an application like this. So what I'm going to do is I'm just going to carefully brush it on there, and all we're trying to do is coat it so that this will lend some support to the areas that are a little bit dry rotted. I've already cleaned everything thoroughly in here, obviously. The method we used using the acid-free glue to strengthen those fibers, that worked like a charm. I mean, that is really nice and firm in there. So the way that I'm going to address the holes that are in the wrapping on the armature is I'm just stuffing each one with a little bit of wool yarn. This motor is rated to run on Class A insulation anyway, because originally all the wiring was cloth covered. So it doesn't really get that hot where you're worried about, this being combustible or anything like that, because all this wrapping was made out of natural materials anyways. So I'm stuffing a little bit of wool yarn in there, and then I'm going to coat that up with some nice grade caulk. And then after it's dry, I will go ahead and I'll paint it. Reason why I got the wool yarn in there is if I ever need to remove it, the caulk is just stuck to the yarn and not stuck to anything important. So the whole thing will come out of there if it was necessary to remove it. If you look at that repair there, I got the wool in there. I got the caulk in there. Now that needs to dry, but that's nice and neat. Once we paint that, that'll look great. Okay, there's our repaired armature. I think that looks pretty good. We didn't tell anybody we made some repairs on there, they wouldn't be the wiser. I decided to change my plan of attack, and I'm going to make my own sheathing for the wiring instead of using the cloth covered wiring. by making my own and sliding that on there, it'll just be easier to conceal where we had to solder the leads on the coils. I want to do a neat job on it. So I have these beautiful, these are 100% cotton, nice sheathing, which will slide over this wire. And I have some dye in here. I'm just going to go ahead and I'll dye these like a nice brown color, something like that. And then maybe hit them with a little shellac. And then we'll make our connections, and then we could slide these sheaths on there. And I think the end result of that is going to be neater. Okay, our cotton sleeves are in place. They've been dyed and hit with a coat of shellac. Working on some miscellaneous aspects of the project. One, chasing all of our threads, using the tap and dye where necessary, cleaning everything up. Number two is these little oil drain plugs were missing the gasket, so I used my gasket cutter set and cut out a couple new gaskets for that. And three, I need to make one little cover for the oil slot. One was missing, so I'm using the existing one. I sprayed that with black spray paint. That'll make a template. I'll cut this little corner out here and I'll glue that to a piece of plywood. And then once the brass is glued to the plywood, I'll cut the whole thing out on the scroll saw, and then I'll use the die filer just to smooth up the edges on it. There's the oil well cover I fabricated. Came out looking real nice. I just went ahead and reassembled the switch assembly and the brush holder housing. I already showed the disassembly earlier in the video, so I reassembled that exactly the opposite of the way we took it apart. We are missing one shoulder bolt that goes right there and one washer. Utilizing the supplies I already have on hand, which is close but not exact, I had these little knurled nuts right here. I got that Loctited onto that bolt. When that dries, I'm going to put that in the lathe. I'll turn off the knurling, face it, and I'll put a slit in there and cut that bolt. That'll be almost an exact replica of the other one. Another thing that we're doing is I had to find another brush. This brush right here is broken off real short. This is probably the culprit of why the brush holder was scraping up against the commutator, as I pointed out earlier. Anyways, I was looking through my assortment of small carbon brushes, and I found this one here, which is pretty darn close to that one. So I think we're going to roll with that. And once we get this in place, we'll use our brush seating stone, and we'll make sure that that's making good contact on there. So we're making good progress. Now I'm machining another bolt to match the one that's missing. I'm holding this with a Jacob's chuck. This is not ideal, it's sticking out a little bit further than I would like, but I don't have the exact collet to fit that small piece. It kind of slips in the collet, so at least this Jacob's chuck is providing us with a firm grip. So we're going to turn that down and face it off, and it should be a nice match. I'll just cut a little slot in there. There's our newly machined bolt. That'll work just fine. You know, I had checked this armature earlier, but I don't know, I can't find the video. So I have this thing set up on the growler here just to show you that the armature check is okay. Now in this particular growler, when this thing is plugged in, these probes are live with 120 volts. So you don't want to inadvertently grab the ends of the probes. That's just the way that some of these old ones work. Anyways, when I go around and I check this, you can see that all the segments have continuity there. And also when I checked it with the hacksaw blade, everything is perfect on that. Using the witness marks that we made when we took this thing apart, I placed the coils and the pillars into position, but I haven't secured them yet. It's about time to start doing some reassembly on this. And the first thing I'm going to do is put this bracket in here. When I put these screws back in, I'm putting a drop of oil on each screw just to lubricate it in case we got to take it apart again. If I'm blocking the camera, I apologize in advance. There's not a ton of room in here. Okay, now the square head bolts that secure the pillars into position, and I'll just tighten those by hand for right now. I'm not going to secure those permanently until we get the armature in there and we have those positions so that we make sure they're not rubbing against the armature. So we'll just snug these by hand. There's one. And here's the other one. Putting a little oil on it. Okay, great. Now we're going to go ahead and I'm cutting these leads to length, approximating how long they need to be with the switch installed. And on the ends of these, I'm going to tin them with a little bit of solder just so that the strands don't fray when we tighten them up. And then underneath here where this sheathing is, I'm going to put a little bit of silicone, just a drop in there, just to secure that in place and to keep those loose ends from fraying. Perfect. I'm going to go ahead and do all the rest of those in the same fashion, and I'll get the leads screwed onto the switch, and I'll bring you guys back. All right, so we're carefully going to start putting the armature and the housing, everything back together. So first thing is there's a couple spacing washers. Anytime that you're working on an electric motor and you remove any spacing washers, you always want to pay attention to how many there were and where they went, because they're real important. So we got that on there. Now, this front housing, we're going to have to hold the ring for the ring oiler up with a pair of tweezers while we put this thing together so that it could slide over the shaft. Okay, there's that side. Now, I've already put the brush holder assembly back on there. Okay, now slide that in there just like that. Now we're going to put the bolts in that secure the housing to the main casting. I'm just going to finger tighten these for now. And there's one. And here's the other one. Okay, good. Now what I'm doing is I'm checking the clearance of the rotor here against those pillars to make sure they're in the right position and not hitting anything. Once we're sure of that, tighten down those square head screws that hold the pillars in position. That looks good right there. When I turn that, doesn't seem like it's hitting anything. So let me get those square head screws tightened up. Okay, now we're going to get our brushes installed. I want to adjust that so that the spring is keeping just a little bit of pressure on there. Like that. Get our name tag on there. That's always a nice step. I still have to put a couple more sleeves on a couple of those wires. Get that done here shortly. And now, temporarily put our Mickey Mouse nuts on here. me get the last of these sleeves on those wires and we'll be ready to give this thing a test run. We got the last of our wire sheathing in place. It looks great. When I'm completely done with this, I'm just gonna weather these slightly just to tone them down a hair, make everything look a little bit more worn in, so to speak. One of the last steps we got to do is I'd like to put a pulley on here that's different from the one that was on there, because that one was a new pot metal one. In my collection of pulleys, I have this one here. This is an old, looks to be cast iron pulley, but number one, it's a little bit too wide for this, and the bore is a little bit too big. There's already a brass insert pressed in here. I think I'm going to press that out. I'll press a new piece of steel in there. I'll see what I got laying around in my drop box, and then we'll go ahead and we'll get this indicated on the 4-jaw chuck. We'll bore that out to the right size, and then we'll drill a hole this way for a set screw, and I might face off these, make them a little bit thinner so that we can take that down a little bit to fit on there. Anyways, let's get over to the arbor press and get started. All right, we got some movement out of it that time. Just took a little bit more heat, a couple curse words. There it goes. So here's the pulley that we modified. I mean, that really looks fantastic. I weathered it up a little bit. And while we're on the topic of weathering, I actually use some of my weathering powders that I use on my model railroad, and I toned down, for example, the cloth sheathing here. See, I dirtied that up a little bit just so that everything blends in, so that everything looks natural. You look here, I weathered the armature a little bit. I mean, our repairs, they look perfect. You know, it has just the right amount of imperfections in there to be believable. Here's the other side. I mean, that came out fantastic. And here you can see where I toned down the wires just a little bit. Okay, now what I got to do is I'm going to fill up the oil reservoirs. Just a reminder, this does have ring oilers. So we're going to get that filled up. And we're going to take this bad boy for a test drive. All right, we're going to go ahead and fire this thing up. I got the winding set in parallel, what would be considered the fast speed, because I'm only going to start it up with about 18 volts. So it's already going to be going slow enough the way it is. Let's fire it up. I couldn't be happier with the way that turned out. It looks old, but it looks well preserved. Exactly what we were shooting for. I'll try to bring the microphone a little bit closer to the action here. Is that not the sweetest sound you ever heard? All right. Gonna call that good.